Hey, and we're back at it. All right, so looking at our lesson 3 here, we're going to be factoring with what we call a greatest common factor. Now, factoring is kind of the opposite of distributing. We're going to take something out instead of put it in, which leads us to, yes, you've guessed it, those 3 warm-up questions there at the top. So what I would like you to do is pause the video, give those 3 warm-up problems a go, distribute, and then write your answer out. And while you're doing that, I'll give you some of the greatest show, since we're talking about the greatest common factor today. All right, so hopefully you're finished with the opener here. Now, all we're doing is taking what's on the outside and we're distributing it into everything on the inside. So we're going to do 2 times x and 2 times 2. All right, and that would give us 2x plus 4. All right, now we move to example 2 here in our warm-up. We're going to distribute that -3, and this time, all right, we have 3 things to distribute it to. So -3 times x squared, that would be -3x squared. -3 times 5x would be negative, and then 15, and then that x. And then -3 times -6, and negative times negative would be a positive. 3 times 6 would be 18. All right, and looking at our final example, and you can really see that we're starting to see a lot of the same elements that we've discussed over the last 2 or 3 lessons kind of popping up and seeing those ideas again and again. All right, so distribute that x here, we get x cubed. Distribute the x all the way here to that positive 10x. That would give us a positive 10x squared. And then taking that x and distributing it way over here to this guy would give us a positive 2x. And then once again, as we look at all of these different things, right, after we've done our distribution, all right, I'm just going to clean that little guy up right there a little bit so you guys can read that clearly. All right, once we've done all of that, then what you see is our answer is in standard form. Now, what we have to always check once we distribute, once we multiply, is do we have any like terms? And in this case, we do not have any like terms. All right, so now what we're going to do now for today's lesson, that's distribution. So we're taking whatever's on the outside, we're distributing it, multiplying it times everything on the inside. Now what we're going to do is reverse that process. And this is a really, really big idea, not just for today's lesson, but in mathematics in general, that everything in math has an inverse operation, a way of undoing what we just did. So now what we want to do, all right, is look at the idea of what we call a greatest common factor. So as I scroll down here, all right, so you can see that all of those answers share a common term. Well, that common term is what we multiplied into it, all right? And now what we're looking for is the greatest common factor. So when we look at that, we're actually going to start at the end and try to go back to the beginning. So try to figure out what was the biggest number, that's why we mean by greatest, all right, the biggest number that was multiplied into our 2 terms, and take that back out, or basically undistribute. Now, just like what we did, and maybe I'll scroll back up here, all right, is that our greatest common factor can be just a number, like it was in our second example. It could be just a variable, like we see in our third example, and we didn't give you an example of this, but it could be a combination of a number and a variable, all right? So let's go down and just take a real quick look at some of these examples. So here's what we're going to do. We're going to look at each term, and we're going to start with each number, so 27 and 9. And what I want to ask myself is, what is the biggest number that I can divide into 27 and that I can divide into 9? And in this situation, that number, let me switch up here. I'm going to switch colors and just the thickness here. So when I look at this, the biggest number that goes into 27 and 9 is, in fact, 9. Now, what I'm going to look at next are my variables. Well, I have an x here, but I don't have any x's here. So x is not common to both terms. So because it's not common to both, I can't undistribute or take it back out. So now what we're going to think about doing is undistributing or factoring out. Now distribution, when we put it in, is multiplying. So factoring, when we take it out, is dividing. So 27 divided by 9 would be 3. And that's a kind of a funky looking 3, but it's a 3. All right. And we still have this 1x right here. So I'm just going to bring that x down like this. And now we have this positive 9. Now positive 9 divided by 9 is a positive 1. And you can see this problem looks just like what we started with above, all right, where we had something on the outside and we distributed in. Now here's the great thing about factoring. You will know if you are correct, because if I distribute back into the parentheses, all right, just like what we did in the opener, I should get exactly what I started with. So if I look at this problem, if I do 9 times 3x, right, I get 27x. And if I do 9 times 1, it's a funky looking arrow, I get 9. And you can see that that's exactly what we started with. So the idea is that we're just going in reverse and thinking about, okay, what was the thing that we multiplied to everything? All right, so what I want you to do real quick is just pause the video and try to attempt number 10. Oh, I'm sorry, number 2, which ends with plus 10. So try number 2 here. All right, so let's take a look. Let me switch colors here. I'm going to go with blue. All right, and I don't know why the thickness keeps getting changed, but we'll try this. So when you look at this, all right, the biggest number that I can divide into 70 and the biggest number I can divide into 10 is actually 10. Now, once again, when I look at my variables, there's nothing common to both terms, so I don't have to worry about taking that out. And so now I can figure out what I started with. So 70 divided by 10 is 7, and then I still have my n. And then 10 divided by 10 is 1. And then there it is. And now, once again, 10 times 7 in is 70 in. 10 times 1 is 10. I'm good. That's what we started with. I know I'm right. Now, when we look at examples 3 and 4 here, these are going to look a lot like the warm-ups that we did. And in fact, when we look at these are just going to be a GCF, or a greatest common factor, that involves a variable. So when I look at my coefficients, I have a 2 here and I have a 1 here. Well, the biggest thing that divides 2 and 1 is, in fact, 1. And if it's 1, we don't need to factor it out, because when I multiply 1 or divide by 1, it stays the same. So now I'm going to look at my variables. Now I have 3 x's here. I only have 1 x here. So how many x's are common to both terms would only be 1. So I can only take 1 out. And the shortcut here is that the GCF for your variables would be the least power. All right, that will tell you how many each thing have in common. So now there is no number or coefficient to take out. So now if I take out 1x out of these, all right, we still have the 2 here that we started with. All right, but notice x cubed is really 3x's. Well, I took 1 out, so that would leave me 2 x's to multiply. Now I only had this 1x, and now I have factored it out front. Now here's where we have to be cognizant of which operation we're using. It's division. So when I take this x and I divide by this x, that would leave me 1. Just 1. And now, once again, if I distribute x times 2x squared is 2x cubed, x times negative 1 is negative x. I can see that I have what I need. All right, and what I started with. So now let's shift and look at number 4. All right. And so if we look at number 4, once again, when I look at this, notice both terms are negative. And typically, if both things are negative or everything is negative, we typically factor that negative 1 out. And in this case, that's the only thing that's common to negative 3 and negative 1 is, in fact, negative 1. Now, let's look at our variables. I have 4 n's here, right? And so just to kind of emphasize this, I'm going to write out my n to the 4th, right? And maybe a little slow here for some reason. It keeps getting bogged down. All right, so that's n to the 4th, right? And then in the second group here, I have n cubed. So n times n times n. Now remember, common. What's common to both? So notice, there's 3 n's in this group. There's 3 n's in this group. So that means I could take 3 out of both groups. So that means I can take n to the 3, or n to the third power, out of both groups. Now let's see what was left. So negative 3 divided by negative 1 would be a positive 3. Now I had 4 n's. You can see that. I take out those 3 right there. Now how many n's do we have left? I have just that 1 n left, right? Now notice I only had 3 n's here. I took all of those out. So there are no n's left. But this is really a negative 1 divided by negative 1. So that gives me a positive 1. Just like that. All right, and then once again, if I redistribute, you can see that that is in fact what we started with. All right, I'm going to do one more with you here, then I'm going to let you have a little bit of time to work. And I just want to emphasize that the process, once again, does not change whether I have 2 terms like I do up here, a binomial, or 3 terms here, a trinomial, like we do. We still go through the same process. So I'm going to look, I have negative 8, 56, and negative 56. So I want to find the biggest number I can divide into all 3 of those things. All right, and that number would be an 8. Okay, my pen is really slowing down. Now, once again, I look at my variables. I have p to the 4th in the first term, p in the second term, and there are no p's in the third term. So p's aren't common to everything, and because they're not, I can't pull anything out. So just this 8 is my common factor. So now, my pen is writing on its own here. Let me just erase that and see if I can actually do a parenthesis here. Come on, you can do it. All right. Okay, so let's go back and let's look at what we have here. Okay, so if I take out an 8 here, all right, so negative 8 divided by 8, that would leave me negative 1. And then I still have my p to the 4th. All right, and then 56 divided by 8 is 7. And then I still have that p right there left. And then negative 56 divided by 8 is a negative 7. And that's what we have. And hopefully you have a better sense of drawing parentheses. So, you know, working with technology and adapting to all of this online stuff is a challenge for all of us in different ways. So here's what I'd like you to do. Pause the video. I'd like you to try number 6, all right, and see how you go. I'll give you a little bit more of the greatest show here while you work. I mean, who doesn't want to be Hugh Jackman, right? He was Wolverine, and he can sing and dance. Come on. All right, so I know that's what you were waiting for. I was waiting for you to finish, all right, before I hop in and show you this problem. So now, hopefully you have finished. All right, so let's once again look at our 3 terms. All right, so I have a 10, I have a 10, I have a 10. Well, guess what? The greatest number I can take out is, in fact, 10. All right, now when I look at my v's, I have 8 v's here, I have 2 v's here, and I have 1 v here. So how many v's can I take out of all 3? How many are common to all 3? And it would just be 1. So I can only take 1 v out of all those groups. All right. So now, negative 10 divided by 10, that would be negative 1. We had 8 v's, but we took 1 out, so that leaves 7 v's getting multiplied. 10 divided by 10 is 1. We had 2 v's, we took out 1, so we have 1 left. Negative 10 divided by 10 is negative 1. We only had 1 v. We took that 1 v out, so there are no v's left. So there you go. All right, so we have 2 left, and I'm going to let you guys do those 2. All right, we'll check those, and then we'll be finished with our lesson. So give it a go here. All right, so let's take a look at these last 2 examples here. Let me just extend the page a little bit here, maybe. There we go, just to give it a little bit more room. Now notice, once again, the process doesn't change even though the number of terms change. All right, so we have 4 terms, but the process is the same. So we want to look at 21, 30, 12, and 9 and say, what is the biggest number I can divide all 3 of those by? And in this case, it would be 3. Now, I'm going to look at all of my variables. I have 5 r's, 4 r's, 3 r's, 2 r's. So what is common to everything would be 2 r's. So I'm going to take out r squared. Now we have to figure out what's left in each group. All right, so 21 divided by 3 is 7. R to the 5th, and we took out 2 r's, would leave us r to the 3rd. And then 30 divided by 3 is 10. And then r to the 4th divided by r squared is r squared. And then negative 12 divided by 3 is negative 4. We have r cubed. We took out 2 r's. That leaves us 1 r. And then 9 divided by 3 is 3. And then we had 2 r's. We took those 2 r's outside, and so that's all we have left right there. All right, so moving to our final example for this lesson. All right, so we have 50, 60, 10, 10, and the GCF would be 10. All right, so we take that 10 out. All right, write it out front just like this. All right, now we have x to the 12th, x squared x, and then no x's. So notice, if a variable is not common to everything, we cannot factor it out. All right, so it's got to be the greatest common factor, which means it has to be a part of every term, no matter how many terms there are. So 50 divided by 10 would be 5, and we'd still have all those x's. So we have x to the 12th then. Negative 60 divided by 10 is negative 6. And we still have all of those x's here. And then 10 divided by 10 is 1, and we just have that 1x as well. And then negative 10 divided by 10 is negative 1. And guess what? That's it. All right, my friends, that wraps up this lesson. All right, remember you have the notes to look at. All right, give the homework a shot tomorrow, and then I will see you guys and work with you again in just a day or two. All right, take care. See ya.